Tides raise many questions. The first one obviously being, why do they even exist? Why isn't the height of the sea always the same? Are tides caused by the sun's attraction, the moon's, both? This program answers these questions, but along the way not only do other questions occur naturally, we even reach apparent contradictions. For example, suppose the tides are caused by the moon. The moon only passes over each place once every day. So, why are there two high tides? And it certainly makes sense that the tides should be stronger at new moon, when the sun and the moon are pulling the water from the same side. But why are the tides also stronger at full moon, when the sun and moon are pulling in opposite directions, and it would seem that their forces of attraction should cancel each other out, at least partially? To understand why there are in fact no contradictions, it's important to understand that the forces of attraction acting on objects cannot be seen within a static model like this one, which does not take into account the movement of the bodies. If the Sun, Earth and Moon were placed in certain positions and left there, they would crash into each other due to gravity. So in order to explain why this doesn't happen, we will begin by considering a model with a rigid frame holding two bodies and explore the conditions of mass and speed which make the frame unnecessary. We are then left with the two bodies connected by a rod rotating around the center of mass. Introducing the attraction of gravity, we once again explore conditions of mass and speed, this time to make the rod unnecessary. We then consider a final model, which has some similarity with the first static model, but this one takes the movement of the bodies into account. This model finally solves all the apparent contradictions and gives a full description of the daily and monthly behavior of tides and the timing of spring and neap tides.